In this video, we will be doing a quick introduction to polynomials. So first we have some terms that we need to define so that we can understand what we're being asked. So a term is a constant or the product of a constant and one or more variables. I'm just going to read through these and then we'll talk about them in the examples below. A coefficient of a term is the number in front of a term. The leading term is the term containing the highest exponent on the variable, regardless of its position in the expression. So this is key. So the leading term does not have to be first in the expression. It just has to have the highest exponent. Normally we write our expressions in descending order according to the variable's exponent, but it's not necessarily written like that. So the leading term is the highest exponent on the variable. Terms that are either constants or have the same variables raised to the same powers are called like terms, and you can combine like terms. So let's look at some examples. For each of the following expressions, identify each of the following. We want to identify how many terms there are, the constant term, the leading term, and the coefficient of each term. So for number 1, keep in mind that terms are separated by plus or minus symbols, addition and subtraction. So if we don't have that, that means it's all together as one term. So in number 1, this is one term. So let's go through 1, 2, 3, 4, and first see if we can figure out how many terms we have. So if I'm looking at the terms for number 2, I can see a plus sign and a minus sign. So this is going to be what separates my terms. So my first term is 5x. My second term is 2. And I put the symbol with what follows it. So the negative 3x cubed would be the third term. So this expression has 3 terms, 5x, the 2, and the negative 3x cubed. So 3 terms in this polynomial. All right, number 3, we have the 15y, and then we have a plus symbol, so plus 12, and that's it. So those are 2 terms. In number 4, we have quite a few addition and subtraction signs. So we have 2z to the 4th, then we have a negative z cubed, then we have another negative 3z squared, then we have a plus z, and then we have a minus 8. So in this one, we actually have 5 terms. So hopefully after seeing those examples, you can pick out where a term starts and where a term ends and see how many terms you actually have. That's important. Now let's go back and look for the constant terms. So the constant term is going to be the one that has no variables attached to it. So in number 1, we only have one term. That's not a constant because it has an x. So in this one, there is no constant term. In number 2, the 2 is by itself. So that's the constant term. In number 3, we have the 12 by itself. So that's the constant term. And in number 4, we have the negative 8 by itself. So if I was going to write it, I would be writing the sign as well. So the constant term for number 2, I'm going to write it over here, would be 2. Oops, there we go. Okay, the constant term for number 3 would be 12. And the constant term for number 4 would be negative 8. So it does include the sign in front of it. All right, next we want to talk about the leading term. So the leading term, I'm going to call LT for short, leading term. There's only one term for number 1, so that is the leading term because it's the only one. In number 2, the leading term is going to be the term with the highest exponent on the variable. So the first term is 5x, the second one is a 2, and the third one is negative 3x cubed. This cubed, that's the highest exponent. Remember, the exponent on the x is understood to be a 1. So the leading term is negative 3x cubed. Again, it's not leading as far as being in the front. If we wrote it in descending order, which is what our preference is, we would write the highest exponent first. Then we would write the next highest exponent, which would be plus 5x because it does have a variable, and the constant goes last. This would be in descending order, and this is our preference. And if it's written in our preferential way, like this, the leading term is in fact the first term. But if it's not written in descending order, the leading term may be in a different position, and it's determined by the highest exponent on the variable. So the leading term for number 3, we only have one with a variable, so 15y. And then the leading term for number 4, the highest exponent is a 4, so 2z to the 4th would be the leading term. And then the last thing it asks us to do is find the coefficient of each term. So in number 1, the coefficient of the term that we have is 13. So the coefficient is 13. In number 2, we've got 3 terms. Each one is going to have a coefficient. So here the coefficient is 5. Oh, and I wrote a 3. It's 5. Here the coefficient is really just a constant, but we can say it's 2. And here the coefficient is negative 3. So the coefficient is just the number in front. In number 3, the coefficients would be 15 and 12. So those are the 2 terms. And then in number 4, we have a 2 is the coefficient. That's the number in front. This coefficient, there's nothing there. Remember that it's understood to be a 1. If there's not a coefficient, the coefficient is understood to be a 1. So negative 1 is that coefficient. This one is negative 3. This is understood 1. It's positive, so 1. And this one is the constant term, negative 8. Okay, so all of that we're going to use, let me erase this stuff, when we're talking about our polynomials as we work through some different expressions or equations later. So simplify each expression by combining like terms. So what we want to do is identify like terms and put them together. And let's go ahead and get used to writing it in descending order. It's not something that you probably have to do at this point to get it right, but it's just a good habit to go ahead and start forming. So in this example, number 5, I have 10a, and that's like with negative 5a, and then I have 7a. So all of those terms have a's, so they're all like terms. I also have constants, so I have a 7, a negative 2, and a negative 4. And those are all constants because they don't have any variable attached to them. So we can combine these. All of the stuff in red, we have 10a minus 5a plus 7. All you're going to do is add or subtract the coefficients and leave the variables the same. So 10 minus 5 is 5, and then 5 plus 7 is 12. So 12a is what we get when we combine like terms with a. And then we're going to have the blue, which is constant terms. So 7 minus 2 is 5, and then 5 minus 4 is 1. So 12a plus 1 is our simplified expression. Notice that we don't add the 12a and the 1. We can't say 13a because 12 has an a and 1 does not. So those are not like terms, so we leave them separate. All right, number 6. We have 10x and we have a negative 13x. And then the 2 is a constant. That's the only one that's like that. So we can combine our like terms. 10x minus 13x is negative 3x. And then bring down the plus 2 because there's no like terms for that. And that's it. Okay, let's look at number 7. So number 7, we have 3x squared. We have 14x squared. These are different than x, like let's say 8x. I would not box that in as like because it doesn't have the same exponent on the x. So x squared is different than x. So we're going to combine our x squares together. Then we will combine our x's together. So negative 12x and 8x. And then we will combine our constants together. So if we do that, we want to write the one with the highest exponent first. So that would be 3x squared plus 14x squared would be 17x squared. Then we would do what's in the blue circles. Negative 12x plus 8x is negative 4x. And then we would combine the constants 11 and 5 and we would get 16. That's in descending order and we've combined all like terms, so that's as much as we can do at this point. Number 8, same thing. We've got negative 3x and a positive 3x. So those are our x terms. And then we have a positive 10 and a negative 12. If we're looking at the x terms, we have a negative 3 and a positive 3. Those are opposites. So those cancel out because they add to 0. So those are gone. Now all we have left is the constant terms, and that's 10 minus 12, which gives us a negative 2.